Today on the channel we're going to be doing an epic build over 1 hour, step by step on how to build your own DIY portable power supply. So hang in there, let's have some fun and let's build this. Okay guys, welcome back to the channel, and as in the opening we're going to be building this power supply today. It's been about a month since I've posted a video. The main reason being is because the next thing I was doing was building this power supply, and after we built all 7 of these cells, we have to let them sit for about a month just to make sure they haven't been self-discharging. What happens is if the chemistry is incorrect in the cells, they can actually self-discharge their voltage. So we just want to make sure that that hasn't happened in the case of these large cells that we've built. So we're going to go ahead and use our multimeter and just confirm that the cells are still within an acceptable voltage of what we charged them to prior to storing them for a month. So let me go ahead and hook up the multimeter and let's check all 7 of these cells. And as I was stating earlier, batteries can self-discharge if they have an issue with the chemistry in the battery. So that's why we're going ahead and check this. This one's at 4.18. 4.18 for the second cell. 4.18 for the third cell. 4.18 for the fourth cell. 4.18 for the fifth cell, 4.18 for the sixth cell, 4.18 for the seventh cell. I did not expect these to have self-discharged, but I test them anyway. We did use new recycled cells, which means battery packs that we stripped down with cells that had never been cycled. So that's why we get such good response when we go ahead and put these into our larger cells to utilize in our battery supply. We are using a 24 volt battery, so this is a little bit more power than a 12 volt battery. So once you start to get 24, 48 or higher, you can have a risk of electrocution, so please be careful when you're doing all of this. Okay guys, I have a little bit of electrical experience. I do have a degree in heavy vehicle and forestry, which is diesel mechanic. So I have a little bit of training, not a lot. I'm not an electrician, but I do have that to stand by. So now that we've gone ahead and hooked everything in parallel by hooking up all the negatives and all the positives to all 7 of our cells, we've created one giant 4.2 volt battery. And the reason we're doing this, of course, is to top balance. You always want to make sure you top balance all your cells before you build any power supply. That way you have a more efficient unit. So for charging these batteries and top balancing, I'm going to utilize our EBC A20 volt battery charger, because it really doesn't matter, because it's using such a low voltage. We can only put a low amount of amps because of Ohm's law. If you're interested in what Ohm's law is, it's volts times watt, or volts times amps equals watts. You can look it up. It's one of the many things you'll learn when you go to school, but it's pretty simple. It's how we work out the capacity of a battery and a few other things. So I'm going to go ahead and hook these up. I like to always separate the areas where we hook them up to, just because I like to get a good flow of electrons through the battery. It makes everything charge a little bit nicer. So this is what I understand. So, but like I said, I'm not an electrician. My knowledge comes from a heavy vehicle and forestry degree, which is a diesel mechanic degree. So. And as you can see, our one big battery is now at 4.164 volts. And one of the other reasons we also want to put a current through it is because, and when I say current, I mean amps, is because it will balance faster with a current running through it rather than just letting it sit here. Like, we could individually charge these batteries to 4.2 volts, hook them together, and they would balance after a week. But I really don't want to wait another week after waiting a month to see if these guys self-discharge. So let me go ahead and set the parameters. So we want to go ahead and charge these at a constant voltage. We're going to go ahead and stick 5 amps into it. We're going to charge them to 4.2 volts. And when this drops to 1 amp, it'll actually end the charging. So at this point, we are good to go. This is all set up, and we're going to go ahead and turn it on. So this is going to take a few hours to finish doing this. Once this is finished, we'll get back and we'll start to look at all the parts that we have and everything else we need to plan prior to building our portable power supply. Okay then, the top balancing is now complete, and after the charger has switched off, we are now at 4.186 volts. Once you take the current off, because the battery charge just drops a small amount. So we're actually doing pretty good at this point. So now we're going to go ahead and pull everything that we need to build this power supply today. We're going to lay it all out, and we're going to plan the build. Make sure that everything fits and the layout is correct. So I'm about to lay out all of the parts that I've bought for this project so we can have a look at them to decide how we're going to lay out this portable power supply. The only thing I did prior to the video was to remove this handle from the top of the tray in the top of this toolbox, so I could see if our inverter would fit nicely into this spot, because this is the most important thing, to make sure this fits and to see that the lid actually shuts, and we have plenty of clearance for the fans and everything else that we may need, and still provide some decent support. So as you can see, it's a little snug, but it does actually fit and it does actually close. So this will work perfectly for our portable power supply, and it's a good size as well. So let me go ahead and lay everything down on the floor, and we can have a look at everything, and we can start deciding where exactly we want to put all of these parts. I was able to go ahead and get everything put up on the workbench here, but let's have a look at everything that I want to put into this portable power supply. There's no fancy gadgets, it's just really simple. That's less wire. Really, one of the most expensive things about building these is good quality UL listed wire. It's quite expensive these days, so we want to make sure we're using that. So we want to make sure this is as simple as possible. So we do have our 800 watt reliable 24 volt inverter. We have a 24 volt 60 amp BMS. The reason we went with this is because this inverter cannot pull more than that, so this is more than what we need. We also have 2 power cables which will plug into the front of the inverter and then go to our external plugs, a couple of switches to turn each of those off. I do have 2 USB ports. These are 24 volt USB ports. The reason I got these is because these put out 100 watts. So they can charge pretty much every modern device, and laptops, tablets, anything that is produced which has a power charging through a USB-C, these will charge. Couple of internal battery posts so we can hook up all the wires, a couple of vents. This is a automatic breaker which will come in from the external tabs here, which I'll use to charge the battery. This is truly a portable power supply. It's not an AKA solar generator, because I don't have a solar charge controller in it, because in this particular case I do not need to hook this up to solar panels. This will be charged with this whenever needed. This puts out 20 amps, as long as you have a power supply. And I'll talk about those later, because everyone raves about these ISDT chargers, but no one says in any of the videos you have to buy a $100 power supply to run them. So you might as well get a Victron charger. It ends up costing about the same amount of money. But this is all that we need. I mean, a couple of USBs, 2 external power ports, because I'm just running major equipment of this, regular household appliances. This will run a refrigerator, a washing machine, all of those things. And I'll do a demonstration once we're finished to show you exactly how powerful this actually is. The few things that it won't run is a microwave, obviously, because it does only put out 800 watts, or a air fryer, which also most of those run around 1500 watts. But we do have a 2000 watt reliable inverter, which we'll be putting into a really big portable power supply, which will be a true solar generator, because I will put a charge controller in it. So let's kind of pull the toolbox and see how our batteries are going to lay out first, before we decide on exactly where we're going to put all the external mountings, because we have to make sure the batteries fit in and fit in safely. All right, so let's start by laying out our 7 cells into our toolbox, just to make sure that they fit and we can wire them in series correctly. This is most probably the hardest part of the build, to actually get these laid out correctly, because usually the best orientation for the battery normally doesn't work with everything else that you want to put in here. So you want to go ahead and play around with all of the cells to get them to fit. So the ideal orientation would be this, which would go, this would be our first, would be our positive, and then we'd go from this up to here. So you go positive, which where we click our main positive to negative, and then negative would go to positive, and then you'd need to also go from negative back to positive again, and then we want to go from our positive to our negative, and then we want to come up. So far we're running from the bottom up here, around to here, down to here. So the next one will have to be our actual positive to hook up onto that, and we will need to make some little jumpers for all of these to connect it, and then to our negative. And I did make one mistake, so okay, let's start again. I didn't leave enough room. So so we want to start at the bottom. So wait a second, so we want this to be up here, our main positive, and we'll go from our negative to a positive, and then positive, negative, and then this needs to be here. So this here will go like so we'll go start here, connect to our main positive, come across, come up, come across, go down, and then we'll finish off over here with this here, and then at the very top we'll have our main negative. So that kind of works okay. Let's make sure everything else works just fine. All right, first problem, this does not fit, and this is already really snug. All right, different orientation. We can't put them up, so let me play with it a little bit, come up with an orientation that works, and I'll be back. So I was able to come up with a configuration that works and still allows the lid to fit on, but my only issue being is I will have to run some 6-gauge wire bus bars, or bus bars, whatever you want to call it, add some lugs between the end of these sides, which will work. So that's the configuration that we have at this particular point, which will give us our main positive and our main negative of our 24-volt battery, and our lid fits on perfectly. And then we stick on our reliable 800 watt inverter, which goes down nicely here, and close the lid. Alright, so there we have it. Now we have to decide where and how we're going to actually lay out the front of this so we can actually, there we go, still a little snug, but like I said, once you put it together you don't actually pull it apart again. So it's alright. Let's look at the layout for the rest of the switches. Okay then guys, so on the setup, I've been looking at this, put one of the cells back in to give me an idea of where I want to lay everything out. I've got this battery disconnect, which I'm just going to put on the front here. So it'll be on the opposite side, right at the front here, coming through, easy to access. So this is literally just for the inverter. So it'll come from here, and all the other positive leads will run off this, running up to the USBs and running to our digital voltage gauge on the front. So that'll be on that. The two USBs and the switches for the USBs and the plugs, I'm just going to put them onto the side of the actual unit itself. So with these, I'm going to put them on this side over here, and then have the switches for each one of these opposite, and then the USBs I'm going to actually stick up high up here with the switches on the inside here for those. These are wired directly to the battery, so it'll go directly to the negative terminal, and then it'll also want to run to the main battery disconnect, because these do have a little LED in them. The face lights up, so we don't want that draining off, as well as to the face of the actual voltage meter, because as we'll have this closed up at all times, we do have a little voltage meter which we can see the voltage of the unit. So our little voltage meter, which is perfect location right at the front of the unit here. I do have a breaker, but I'm not even sure I'm going to use this, because the BMS does have low and high voltage disconnect, but there's no reason for this to ever come close to tripping the breaker, because it'll never pull more than 32 amps. And like I said, the whole thing's set up to run over 60 amps, so we shouldn't be fine. So I don't really see why there'd be a surge. I mean, I could be wrong. Hey, we live and learn, right? That's why we're making all these things, to see how we go with it. So we do have a breaker, but I don't think I'm going to put this in. I got a couple of different ones. This is the type. Just have to change the amperage. If I was going to put one in here, I would actually put a 40 amp breaker into it, but I don't think we need it. But we'll see how we go anyway. So that's going to be the layout. So let me start doing each one of these, and as I do each one, I'll give you a quick update as we go, and then we'll do the final assembly once we have everything together, and then we'll do some tests. I have a really large, heavy-duty Electrolux washing machine, which I want to see if we can run off this. I know it does already run the refrigerator that I have and the freezer, because I've used that inverter before off a smaller battery. I used to have one of these made up with half the size battery. I'm just building this in a different form factor so I could increase the size of the battery. So I know it all works. I'm just trying to make it look a little cleaner and make it a lot less, a lot more simple. As I said, I used to have lights on it and all sorts of different, I used to have 12-volt outputs, but I'm like, what do you really need it for? I only need it to run major appliances or a little compressor that I have or a few other things like that. So I don't need all those extra bells and whistles in it. And honestly, you never use them anyway. They're just a waste of room and effort and money. So let's go ahead and start installing each of these plugs and displays into the toolbox. Okay then guys, I have finished installing all the external fixtures. The first two items here is the battery charging. Because we have our voltage meter on the top, and then we go across to our main power disconnect, and then over to the side here we come around and we do have all of our charging ports. So let's just flip this up for you guys. So as you can see, we have our 2 ports, our on-off switch for each of the ports. We have our 100-watt USB. As you can see, the bottom one is 4 amps. So we're using a nominal voltage of 25 volts. 4 times 25 is 100 watts. And so we do get 100 watts out of both of these. I did add switches to all these. It wasn't necessary. You could just use the main power disconnect to power all these. But that way, these have lights and these have lights. So we're not actually going to use the power whilst we're not using them. In the back of this, I did install a vent on the back, and then we went ahead and also put a vent onto the top. So if we do get any heat, which we shouldn't because we're well under the capacity of this unit. And so there is the externals of our power supply. So let me go ahead and pull out our batteries and let's start wiring this thing up. So what I've gone ahead and done is laid out the cells in the orientation that they fit inside the toolbox that we're going to be building our power supply with. Just so we can make sure that when we build our jumper leads to go from our positive to negative, so we can put all of our batteries in series, so we can, all of our cells in series, so we can make our 24-volt battery. I did also go ahead and added some lugs to our BMS. 60 amp discharge, 30 amp in, and as I stated before, this is much larger than we actually need because our inverter on maximum draw can only pull 32 amps, so this works perfect. I do put lugs on everything. I do have a hydraulic crimp. It's the best way to add lugs. So I'm just going to measure out now the length of all the cables that we need and all the little jumpers we need, so we can actually connect all of the batteries in series. So let me go ahead and take that and add the lugs to all those cables, and then we'll go ahead and set it all up here on the bench before we add it to the toolbox so you guys can get a better look at it. And to make all our connections today, we are using this 8-gauge Windy Nation wire, dual listed. To pick it up on Amazon. As I was stating earlier, one of the most expensive things is good quality wire. The reason I'm using 8-gauge is because I have 2 10-gauge wires coming off the batteries. Each of these is for 20 amps, that gives us 40 amps capacity, and this also is 40 amps. So we have more than enough. We're running the 80% rule, so you want to have something that'll be used about 80% of the power, and 32 amps is about 80%, and this can run 40 amps. So once again, we're going to use about 80% of the capability of these wires, so we never have to worry about heat, and that's in the worst case scenario. That's if we have 2 15 amp items running off the battery at the same time. So I've gone ahead and finished making all the cables required to put together all of our cells in series so we can make our 24-volt battery. I do hydraulic crimp all the ends and use heat shrink. One of the other things I've decided I want to go ahead and do is in one of my previous videos. If you go ahead and subscribe, you can pull up those. I tested this Dowley active balancer. I've decided to go ahead and put this into this portable power supplies just to see how they perform in day-to-day use. I just hooked it up and just did a quick check to see if it met specifications that they stated, and it does. So it's not the most powerful active balancer, but in this case it should do well. And if it does work out, I may actually go ahead and buy some more of them, because you can actually utilize them in just top balancing, which what we need in this particular use for 18650 batteries. So as you can program them. So I'm going to put it in this power supply. So what we're going to do is we're going to use all these lugs as I did in the testing of this, along with these cables that I made previously with making in. I do put ferrules on all the end of the cables that I'm using if they don't have lugs on them. So I just recommend you do that. It just makes a better battery. In a lot of countries in Europe and Australia, this is a requirement of all electrical to have ferrules put onto the end of them. So so instead of having multiple leads coming from the active balancer and the BMS, I'm just going to run this one set of leads off through these, and then I'll run the set of wires going from the BMS and the active balancer through this. We'll just make it a little bit cleaner when we're putting it all together. So let's go ahead and add our jumpers at this point, and let's see if we do actually have a 24-volt battery. So to do that, I have a whole pile of these brass nuts and washers that I bought, and bolts that I bought previously, but I don't use these, so I'm trying to utilize everything I have lying around so I don't spend extra money on this. That's why we're using the smaller toolbox, so they have that, and we're going to make the leads instead because I have all this wire. The reason I'm using the 6-gauge wire, once again, is because this is all we need, the 8-gauge, this is all we need to utilize in the amount of amps we'll be drawing off this power supply. So let me go ahead and hook this all up, and then we can go ahead and test it. So let's connect our battery cells together to make our battery. Remember, we're hooking up our positives to our negatives, or negatives to positives. So we're going to be increasing the voltage that's in series. If we're going to hook them in parallel, we would increase the amps, but the voltage would remain the same. So let's hook all these up and see what we get. So to start with, this is our positive that we'll be leaving, which will go to our main battery disconnect. So then we'll go from our first negative to our second positive with our first jumper. So there we go, we went ahead and hooked up our first negative to our positive. So let me go ahead and hook these up and then I'll come back to you in just a second. So we have gone ahead and connected all of our leads to make one big 24-volt battery. We've gone from our main positive to our negative, to our next cell positive, and then out of our next cell negative, we've gone to the next cell positive, and then so on, out of the negative to the positive, out of the negative to the positive, out of the negative to the positive, out of the negative to the positive. We now have two terminals, our main negative and our main positive. So let's go ahead and check our voltage on that. As you can see, we have 29.147 volts. So we have successfully made a 24-volt battery for our portable power supply. So next thing I'm going to go ahead and do is put this into the toolbox. Or actually, before we put it into the toolbox, we will go ahead and add our additional items, our plugs, our gauges, our switches, so we can wire everything up once we go ahead and put it into that toolbox. So let me go ahead and pull up the toolbox and we'll start working on that. Okay guys, just a quick update before we start messing with the toolbox and setting all the gauges and switches and plugs and so on. I was thinking about this a little bit last night, and I decided to hook up the active balancer along with the BMS through these actual clips here. So I only have to have one set of wires running to all of the terminals in the battery. So seems to be working fine. I can pick up the BMS through the app, and the battery, so I can pick up the active balancer through the app, and the battery is running perfectly fine through the BMS and giving us the correct voltage. And let me just confirm that here. So when we check, like so, and also like so, we're getting the correct voltage. So it'll make it a little bit cleaner, and I want to utilize this, as I stated before, just to see how well it goes, because in our next build I'm going to actually build one of the batteries that I built for the solar systems that I use in my DIY setup for my camper, which I'm going to show you guys a video shortly, because I'm about to install the solar system into that as well. So yeah, so let's give this a try. And so let's go ahead and start working on our toolbox, and then we'll go ahead and get all this installed as we get that finished. So let's go ahead and have a quick look inside the actual unit and what I have installed. As you can see here, the two terminals that we will hook up for the charging. On this side we have the main power disconnect. Down here we have the two external plugs, and at the top here we do have the 200-watt USBs. The problem with these are they're higher than the actual tray that sits in here with the inverter on it. I'm just going to cut two slots out of the top of the tray so it can still drop down where we need to be. That way we can actually have these in a good location on the external part of the build, so it will still work. So let's go ahead and start hooking up all the batteries and connect them all in series, and then we can start wiring the actual switches, disconnect, and inverter. So what I'm going to be doing is building the battery outside of the battery box and then transferring it to, once we put all across the jumpers that we did build to connect all the cells in series, as well as all the balance leads that we made. And then I do actually have rubber tabs that I cover all of the terminals once I'm finished. and I'll show you a look at that. So let me go ahead and put this 24-volt battery together as we did previously in the video, and then we'll move on from there. So the hardware we utilize when putting the battery together for the last time is we do need a hex bolt, a spring washer, and a flange nut. This allows for, if there is any heating and cooling, it allows for the expansion without the extra nuts coming loose, because that is definitely possible with a lot of heat running through the battery. So a couple of things that I am doing during the assembling of the battery with the 7 cells is I'm doing it externally to make sure I can use a shifter and a spanner to make these terminals as tight as possible, because the tighter the connection, the better flow of electrons. I'm also just putting the balance leads to the side right now in this little portable testing rig, because these are live at this point, and if you do mix these up, you can short the battery. So make sure you watch what you're doing when you have these balance leads to the side until we get them connected to our final build. So let's move on. And just a quick reminder, guys, I am using metal tools, and at any time I could short the battery by touching this. I have built a lot of these building up to some of the better builds that I do now, and I have shorted these enough time to be really careful when I'm doing this. But you can always buy insulated tools. These are, I have all DeWalt tools. I could wrap some tape around them. I do actually have some insulation tape, but like I said, I've made the mistake enough times now to be extremely careful whilst I'm doing this. But that is your decision. You can either have insulation or just be really careful, because I guarantee at some point you're going to short one of your batteries in this learning process, which will teach you not to do it again. And hopefully nothing will go wrong during the process. So just be careful. Okay, we have now finished assembling all the cells in series, and we once again have our 24-volt battery with all our balance leads connected. So let's go ahead and drop it into the toolbox and start wiring it. Okay, the next thing I've decided to do before I put it into the toolbox is to actually insulate it. I usually do this after, but I thought I'd do it out here so you can see a better look. I take this 100% pure rubber sheeting. I just buy it at Home Depot. It's Hallway Runner. It's 100% rubber, and I put it between each of the cells where they can short. They won't short from top to bottom because this is where they're connected, and we do have 2 layers of Kapton's tape, but for any reason, if they do rub on the edges here, even though we're well away from the edge with the nickel strip, we still got a little bit of room. We do add this extra layer of rubber to make sure that we do have an insulation barrier. I'm also going to now add rubber stoppers over the top of all the ends, and so I just get rubber stoppers. I actually buy the ones from Menards because they're the perfect size, and I just heat them up with my heat gun, and I just push them over the top of here and put a zip tie over those. So let me go ahead and do that and show you what that looks like. Okay then guys, we've now completed our battery. As you can see, I went ahead and I connected these rubber stoppers on the end of all of the terminals with a cable tie. I actually get these from Menards, as I said. I think they're 3/4 inch rubber stoppers. I split them on one side, heat them up with a heat gun, they slide straight on, and then put a cable tie to hold them on. Just helps with a little bit more insulation. And previously added the rubber matting in the middle to make sure we don't short. So we now have finished our 24-volt battery. It does not have the BMS. That's going to be installed in the case because of the way we're configuring it with all our additional cables through these connectors, so we can actually add 3 different devices through these one set of lines. So let's go ahead and drop it in there, and let's start wiring this up so we can get our 2000 watt-hour power supply. The first thing we're going to be doing with the wiring is connecting all the ends of these balance leads. We have 3 different sets of balance leads. One is for the active balancer, one is for the BMS, and the other one is for the balance charger. This way we can keep all of our cells in balance to keep the most efficiency of the battery at all times. So let me go ahead and connect these. This is when you have to double, triple, and quadruple check it, because each of these has to be connected exactly the same. So you have your first positive, your second positive, third, fourth, fifth, sixth, seventh positive, and then your negative. So you have to triple check as you connect them. I'll be joining all of the ends together of each of the first positives through the negative with a ferrule, and they'll actually hook into those universal clips that we have, so we only have to run one set of wires to the actual batteries itself. So let me go ahead and get the ferrules connected, and I'll show you what it looks like once I'm done. Okay then, as you can see, I've taken the 3 wires from each of the separate balance cables, and these are the wires which will be going to all the negatives on the balancer or the active balancer or the BMS, and I put them through onto a ferrule. So when we connect them, it'll make it easy to remove and attach them at a later date if we do need to do any maintenance on the battery. So let me go ahead and finish the next 7. So as you can see, we've connected all of the 3 balance cables together, coming down to a ferrule. This way we are able to connect to our 3 devices as needed when using this particular battery. So let's go ahead and position our active balancer and our BMS so we're able to connect everything. We're also going to be adding somewhere on the inside of the box our connectors that'll run back to our battery for all our balancing lines. Okay, as you can see here, I did the final adjustments. I had to cut out a couple of sockets by the USBs to allow them to sit above the bottom of the tray, and we can still connect them. And down this end, I did drill 1 hole. This will be our negative and positive lines, which will come up to our inverter. So let me go ahead and lift this out, and we'll start wiring the unit. The next thing we need to decide is exactly where we're going to put all of these devices so we can lay it out. I was thinking of putting the BMS over on this side, down below the battery. This way the temperature thermistor or temperature probe can actually come up on the negative wire, because this is usually the hottest part of the battery. We can then connect to the battery and still have this the top negative, because the blue line connects to the negative for the battery, and this will actually go out to your devices, and then you need room to connect your BMS line. So I'm thinking this is like the best orientation for this, and all of the connectors for all the balance leads I'm thinking of putting down here on the inside, which will still allow us to get access to them. It'll be a little snug, but I think it'll work perfectly. And last of all is our active balancer, and I think I'll just run it just straight here in the front. As long as it's below the batteries, it'll work fine, and we'll still be able to get access to all of the batteries. We could even better just orientate it down like so. So that should work perfectly for us. So let me go ahead and get all those attached. The most important thing about all of this is when we remove all of these wires from a little test rig I used to test this balancer previously, I need to make sure I hook them up correctly. Once again, you will destroy your active balancer and you will destroy your BMS if you wire these incorrectly at any of these times. So let me go ahead and start doing that, and we'll have a look once I'm done. So I was looking at our Bluetooth module. This allows us to monitor our battery and our active balancer and the BMS. And I'm thinking of just mounting it on the inside here. It's away from the tray because we do need to actually have access to this little button on the front in case we need to reset it, because this resets the signal and allows you to, this resets the signal here. It allows you to reset your app to receive a signal from the Bluetooth module. So I think this will go here. We'll have the active balancer down here, and as I spoke of before, we're going to put the BMS down on the inside here, which should be, work perfectly. And on the inside, down the side here, we'll put our little connectors for our balance leads. This means one of the lines will connect to our BMS, the other one will connect into the active balancer. The third line will actually just be here, and as needed, when we hook up our when we hook up our ISDT balance charger. So those are the three things we're setting this up, so it'll be easy to monitor and to maintain. So let me go ahead and install all these, and I'll get back to you guys. Okay, I've gone ahead and I've moved everything from the actual test unit over to the ones I'm going to be installing into the battery here. Once again, you have your negative, then you have your increasing of your voltage through all of your positives. And we can test this by using the multimeter to make sure we're wired correctly each time. And I did check that 3 times just to make sure. This is going to mount down here on the inside, and then our other balance cables will actually connect down onto this. So let me go ahead and connect that, and once again I'm going to double and triple check that, so each of these voltages will increase. Between these, it'll be your 4 volts, your 8 volts, 12, 16, 20, 24, 28. So they increase the voltage of each of the individual cells. If for some reason it goes too high or it's not high enough, then we've gone ahead and put our balance leads in incorrectly. And like I said, we need to check this 3 or 4 times just to make sure, because this will destroy our active balancer or the BMS if we do not have this wired correctly. So let me go ahead and take care of that. Okay, then I've finished wiring all the balance leads through the terminal that I made with the 4 clips. I did go ahead and check to make sure that the voltage increases prior to doing this, and then on each and every one of these I also checked you putting in the negative terminal and then increasing the voltage, just to confirm that they all do this, because as I said, if we plug this into any of our devices and we have this wired incorrectly, we will destroy that device. So at this point, I'm just going to go ahead and mount the balance leads down on the side of the cable, and then we'll go ahead and start connecting our devices and wiring everything together. So let me go ahead and take care of that. Just a couple of things to keep in mind. Before we actually insert our balance leads into our BMS, the BMS must be connected. This is a dual wire BMS, so the blue wire on this Dali BMS connects to the negative, and then all our negatives for all of our devices will connect on this side. This is also where we'll bring in our charging to this side as well. So what I'm going to do is I'm just going to connect this one over here, and actually just connect this one over to here, and then run everything off this terminal as well. That way we can charge it when we need to, and this will also power everything that we need, which will come through the terminal here. And then we're going to run one wire up to our main power disconnect, and then from here and from here we'll go up to our inverter. From here and from here we'll go up to the inverter, and then we'll go directly also from these 2 terminals, from this terminal and this terminal, and these will plug directly into our USBs and our switches. So let's go ahead and start wiring everything here. Okay, we've now gone ahead and connected our balance terminal, our active balancer and Bluetooth, and the BMS, and it's all working perfectly at this time. So we're going to go ahead and start wiring up all of the external ports, the 2 USBs and the 2 plugs, and then we'll go from there. So let me go ahead and wire those up and I'll get back to you. The next thing that I've gone ahead and done is I've just made this small 8 gauge jumper, and we're going to run this from the end of the positive for the 24-volt battery up to the main power disconnect, and this will be all our positives will run from this terminal, and then all the negatives will come up to the other side of the BMS. So let me go ahead and hook that up and we'll go from there. When I make all of the cables for all of my builds, I do use a hydraulic crimper and press all the copper lugs onto the cables themselves. This gives you the best possible connection you can have. All right then, let's have a look of what we've got to at this point. So we've come up from the positive terminal up through the main battery disconnect, and I have 2 lines running off the main battery disconnect, one to the external charging port and the other line, which is the line which will lead up to the inverter. Also coming off the BMS, we had 2 lines, one going to the external charging port and the other line which will go up to the inverter as well. So yes, the next thing I'm going to do is to wire our voltage meter, which is here, you can see, and this will get wired directly to these 2 taps here, and then at that point we'll run a negative directly from here to connect to both of these USBs, which will just loop straight across from this negative, and then we'll take one from the positive, which is this positive here, and we'll run this up to the switch and through the switch to the positive, another one through the switch to the positive, which will give us our USBs. These run directly off the battery, so as I said, these are 100-watt USBs. And then we just have to hook up our 2 cables, which will plug directly into our inverter. The earths go directly to the earths, and this is a double pole switch, so both your negative and positive go in to the switch right here, and then both the negative and the positive then come out and go across to your plug, which is on the external. So this is the last things we have to hook up here. So let me go ahead and get all that wired up, and then we will have a fully functional active power supply. So let me finish it up. Okay then, it looks a little messy, but it is all wired appropriately. I have all the USBs hooked up. I have the 2 lines for the exterior plugs, which will plug directly into the inverter. We come down through all the balance cables to the 2 plugs which will power the inverter. So let me go ahead and put the top on it, plug everything in, and then we'll give it a try. All right then, we've gone ahead and we've hooked up our leads to our inverter. The balance leads will just be left to the side until we want to balance charge it, and then across, of course, we just go straight into the top here and hook it up. So let's go ahead and power this up to see what happens. So we are on right now. As you can see, we have 29.1 volts. Let's walk around to the side here, and if you check this out, we turn this on, our USB comes on. These are our 100-watt ones, and then this is not on yet. I haven't powered it up. Let's go ahead and power up the inverter. The inverter is now at 120 volts. And when we flick this switch on, there we go. The switch comes on. Flick this one on, also comes on. So yes, we have finished our portable power supply. It took a bit of time with a lot of other stuff going on, but I'm glad it's finally finished. So tomorrow, it's getting a little late here, about midnight, so tomorrow we're going to do some tests on this to add to the back of the video. So thanks for following along, and if you've been waiting 2 months to see this build, I do appreciate you looking at it. I did have to actually get some work done on my RV, and coming up soon we'll be installing the electrical system into that RV. It's a 1988 Econoline with an American by Cobra body on it, which I fully renovated, stripped the interior, but I'll be only going over the actual electrical setup on that. So yeah, so I appreciate you guys once again. Thanks for watching Step by Step Back to Basics, and you guys have a great day. So before we do include this video, I thought I would try to test this. I plugged it into my TV, it works fine. That only pulls 100 watts. Plugged the PlayStation into, which pulled about 100 watts as well. So it's pulling 200 watts, which is easy for a 600 watt inverter. Plugged it into my box freezer. Worked perfectly fine when the motor stepped up. But I have my Electrolux LuxCare washer machine. And so I thought I would see what happens if I plug this in. As you can see, we have it plugged in down on the side of our external port, which just literally just plugs into the inverter inside through the appropriate power cable. At this point we're running at 29.1 volts. So let's go ahead and give it a try. It runs fine, it powers it up. It's running at the moment, so just do a quick cycle here. Had to run around and look for a few different glows to actually to wash, so I'll just put on a quick wash and let's see what happens. All right. It is filling up the washing machine at this time, so it seems to run. The battery doesn't seem to be too bad. It dropped 0.2 of a volt and it clicked into place. So yeah, it seems to have no real issues. Still filling up. Right up. I thought it had stopped, so I got my headphones in, I couldn't hear. It's actually still filling. I hate these smart washing machines. I've never actually watched the washing machine work before, so. But yeah, so let me go ahead and let it do the complete cycle, and I'll get back to you guys in 25 minutes. But it seems to be working, and this has got some pretty high drawn motors in it to make it spin. So yeah, pretty not too bad of a device we've been able to build here. So let me keep going. Like I said, I'll get back to you at the end of the cycle, and we'll see how much power draw off the battery. I just wanted to do a quick update. It's the first time I've heard the fan clicking in the inverter, so it's obviously the highest power draw at this time. Up to now, the fan on the inverter didn't even come on, so yeah, running pretty good. Like I said before, these are a little reliable inverters are great. For the price, they're amazing. Okay, the cycle is finished and we ended up at 28.5. Started out at 29.1, I think it was. I'll look back at the video, but yeah. We run our cycle through our electric washing machine through a new power supply. Pretty cool. Once again, guys, thanks for watching Step by Step Back to Basics. Subscribe for updates and share with a friend. Thanks again.